Hello, my name is Ezongo Angbenu, founder of Creative Juices, and this is... Boy, you're supposed to say something.
Yeah, Paul Emmanuel.
This is Paul Nwanne from
State.
from the Biafra Medical Association. Paul, you're supposed to say it.
No.
And the topic of this...
This thing.
Anyway, forget. And the topic of this program is Know Your Foods, where we're essentially going to dissect the nature of certain industrial foods, that's this highly processed foods. And in this episode, which is our first episode, is we're going to be looking at instant noodles. So let's get into it. So here I have a sample of an instant noodles. Paul, may they eat all these kind of things?
Yes.
So this thing they're good for your body?
Yes.
Well, as the medical expert, I said Paul is from the Biafran Medical Association. So he's here to provide us a degree of scientific rigor and precision of analysis. So this thing is good in your body when you eat it?
Yes. Even though it's small, you can chop it, it's good for your body. Yes.
So how often do you eat this thing?
After you don't boil for water, for stove, turn up for spoon. After you don't burn, dip up for stove, put them for ground, put them for plate, turn up, chop, take spoon, chop.
Chop on one hand?
One hand.
So that what about this one? They put this one?
You can put this one.
Okay. You see now, I want to talk about this instant noodles. Now,
yes.
Paul, one thing I want to tell you is that this thing no dey good for body.
It's good now.
So, let's get into it. Essentially, there are three aspects of instant noodles that I want to go into because there are several aspects, but just for the sake of time and also for clarity, because it's just the most problematic aspects, I think, that we're only going to look at. So the first really problematic thing is the refined wheat flour, because we have to recognize that wheat is the whole wheat is composed of several layers, right? So just very roughly, and this is not anatomically correct, so to speak, but there are three layers. So we have the endosperm, you have the germ, and then you also have the bran. So when you process wheat into this refined wheat product, you get rid of the bran and the germ, and what you're left with is this starch-rich endosperm, and that's the carbohydrate-rich part of the wheat berry. So you also lose a lot of proteins, a lot of fat, a lot of vitamins and minerals. Not to say that some of that goodness is not in the endosperm, but it's really a depleted food. So that's one thing. You're eating a depleted food, right? Refined wheat flour. A lot of the good stuff has gone, and what you're left with is a lot of starch. So what are the glycemic effects, right? So what I mean is that how does eating this high starch food, this refined carbohydrate, impact on blood sugar management? So that's what I mean by its glycemic effects. And the effects is that when you eat this highly processed wheat, this refined wheat, it digests rapidly. So wheat is basically sugar that's linked up together and gives you that starch molecule. It's rapidly broken up, and it's a surge of sugar. And it's quite surprising how rapidly starch digests in our system. Within an hour, you have most of those carbohydrates already in the bloodstream. So it's relatively a surge of blood sugar. And it's the attendant effects that are the problem, right? So it's how high blood sugar from eating this refined carbohydrates impacts the level of insulin in your body, right? Because insulin is what signals to the rest of your body to absorb that sugar, use it for energy, or to store it as fat, or use it for other purposes. So it's that rush, right? So there's that high burst of sugar, high burst of insulin, and then that happening all the time, right? So you kind of go on this roller coaster thing every time you eat such foods. And it sounds a little bit dramatic, but really that's the biochemistry of this stuff, because this is so unnatural. You know, there's nowhere in nature that you can find carbohydrates associated in this fashion, you know, molded in this sort. So when you eat it, it does also abnormal things just because it's an unnatural food. So this burst of sugar, quite similar to eating, you know, candy, things of that sort. It's not that bad, but it's of a similar sort. So this burst of sugar, burst of insulin, regularly it breaks down insulin regulation in your body, and then you end up with a loss of sensitivity to insulin progressively in various organs, usually starting with your liver and then your muscles and your fat cells. And what that means in terms of disease is that this is the slippery slope that leads to a raft of conditions collectively known as the metabolic syndrome: type 2 diabetes, cancers, high blood pressure, liver disease, also reproductive issues, polycystic ovarian disease. It goes on and on. So this is a hub, and it really starts with foods of this sort. And as they entered the food landscape, you also see a rapid increase in these diseases in the environment, and it's really just how these foods impact our biochemistry. Secondly, gluten, quickly. I used to think gluten was just something that crazy white people used to talk about, you know. It's not real. You know, wheat, this is even biblical. How can wheat contain a protein that is bad for the body? But like, gluten is really complex. It's actually composed of like 23,000 different proteins, right? But some within that medley, within that mix, are problematic. And it's the problematic ones. Okay, for example, one of the proteins that are in this gluten, they break down into a chain of amino acids called 33-mer. So let me just quickly say something about how this gluten protein. So gluten is a lot of different proteins. Some are good, you know, they're just digested, used for energy, but some are problematic. And the ones that are really problematic are the prolamines. It's a family of very tough storage proteins that are resistant to digestion. And the digestion products that you get from these prolamines in wheat, one of them is called 33-mer. What does this all mean? So let's just look at a section of your small intestine and how this breakdown product, because 33-mer is formed in the upper part of your small intestine, where these starches are being broken down by various enzymes. So let's say now we're looking at the midsection of your small intestine, and you have 33-mer. So the small intestine is comprised of a lining, because you know that this is a barrier. There is a, you know, digested food going out of the small intestine into circulation. So there needs to be a selectivity, right? Only good things go in, and not everything that is inside the contents of the small intestine, because there's also a lot of bacteria, both good and bad. There are all sorts of products, you know, and then also, you know, some things that were released upstream, such as by the liver, you know, maybe some toxins that, you know, should transit through the whole digestive tract and be eliminated. So you don't want these things being reabsorbed. 33-mer impacts on a type of protein. It's called a gap junction protein, and those proteins are essentially, roughly speaking, I'll call it like a valve, right, that keeps the gut from leaking out what it's not supposed to, right? So it's an important mechanism for controlling the movement of the internal contents of the small intestine into the systemic circulation, and where it's carried all around the body. So 33-mer loosens these gap junctions, and then it makes the small intestines more leaky. And the health implication of that, just to cut a very long story short, is when you have a leaky gut, it puts you at high risk of autoimmune conditions. So basically, when the immune system attacks the body, and autoimmunity is a part of many conditions. Typically stuff like rheumatoid arthritis, or you can talk about like multiple sclerosis, where your immune system attacks the nervous system, attacks the nerve fibers, right? So essentially your nerve fibers are being destroyed by itself, right, by the immune system. So this is a stepping stone for lots of other problems, all from humble wheat. Now finally, alloxan. So this ties into the commercial logic of wheat, right? Because it's all about storage, having a long shelf life, right? So in order to achieve that, so wheat undergoes additional processes, and one of that is bleaching, and they bleach with chlorine derivatives. And these bleaching products, once they bleach the wheat, okay, it makes the wheat last a lot longer, so that makes commercial sense. But a byproduct of using chlorine to kind of preserve wheat is that it generates alloxan, so it's a toxic metabolite of this wheat processing. And unbleached wheat is in everything, hamburgers, pizza, so we're getting a steady dose of alloxan. So what is this alloxan? This toxic metabolite of wheat bleaching. What it basically is that it targets, it's cytotoxic, it kills cells. And the problematic thing is that it preferentially kills insulin producing cells in the body. So this is the quickest route to having a form of type 1 diabetes or just having blood sugar regulation issues. So it's really problematic. It's even used in labs to induce diabetes in mice. If you want to make a mice diabetic, just give him a shot of alloxan. Kills all the insulin producing cells, and then you now have an insulin dependent mouse. So really problematic, and all this just from this highly processed Franken foods like instant noodles. Paul, are you following some of these things?
Yes.
Are you still going to eat this thing?
Yes.
Next, hydrogenated vegetable oil, aka trans fat. So I'm sure you've probably heard of trans fats as being problematic. Another name for trans fats is hydrogenated vegetable oil. So it's part of how you create something of this sort, because this is not only wheat, there's also oils, they're fats. But one problem with a natural oil, let's say you just squeezed out soybean oil, which is the largest volume of vegetable oil that's produced. You also have corn oil, cottonseed, rapeseed, and so on. But soybean oil is produced in very large amounts, so that's the dominant vegetable oil. If you use soybean oil to make something like this, natural soybean oil, it will go rancid in a matter of days, right? It will smell horrible, taste horrible. So how do you make a natural oil give you an unnatural shelf life? How do you make oil not go rancid for however long such contraptions last? Let's say 2 years or whatever they put on the label. You do that with hydrogenation. It's fancy chemistry. You take a vat with oil, with natural soybean oil, then you heat that vat up, and you add hydrogen gas. That's where the hydrogen and the hydrogenation comes from, in the presence of a metal catalyst, maybe like nickel or some other metal. But just highly toxic chemistry that creates essentially something that's quite similar to a petrochemical. And the reason why I call it a petrochemical, because another term for hydrogenation as a process is plasticization, because you're making a natural oil fully synthetic. And when this gets into your body, because you are what you eat, so your body uses this fat to build your cell membranes. Recall, the fundamental unit of the human body is the cell. And within the cell, there are various things. And how do you create compartments? How do you create the compartment of the cell? How do you create the compartment of the nucleus, of the mitochondrion, of the sarcoplasmic reticulum, or just any other organelle? It's all about creating fatty membranes that creates a separation between in and out, or out and in. It's all about fat, exploiting the fat that oils and waters do not mix. So this is fundamental to life. So when you eat hydrogenated oils, this is what your body uses, because every day billions of cells are dividing and replicating in your body. So you need a steady stream of fat, either stored or from what you eat, to fuel this cell division. And essentially, hydrogenated oils create defective membranes. So you have damage on the most fundamental and essential level, on the level of organelles and on the level of whole cells, which now cascades, creating effects at the level of tissues, at the level of organs, and at the level of the whole body. And another term for damage is disease. What is diabetes if not just damage? What is cancer if not just sorts of damage? What is heart disease if not just damage of various sorts? Unfortunately, can't go into the specifics of that, but this just creates a damaged and diseased body. Once again, these frankenfoods. Finally, let me briefly talk about MSG. Where you get MSG primarily is in this salty pack. I remember when I was quite young, in my school days, we used to grind up this stuff just like, manually, and then spray this salt on it and just eat it just like cookies, thinking it was good chops. Then I used to feel like, those kids that could buy Indomie every day, man. But MSG has many things that is wrong with it. And MSG is also used in this because MSG is very unique. MSG stands for monosodium glutamate, and the unique thing about monosodium glutamate is that it interacts with a taste receptor in the body, in the tongue and the oropharynx area. It interacts with these receptors, and then it makes almost anything taste really good, right? Because it has a flavor that's referred to as umami or savoriness or something of that sort. So it can make roadkill taste good. If you had like a dead possum that had been driven over by a trailer, 3 days smelling, put enough MSG on that and it might become edible. And that is applied. That logic is applied viciously and just everywhere in the processed food industry, because the logic is taking crap and reformulating it into something that appears like food, right? So this is more the appearance of food than food per se. So so MSG is an excitotoxin. What that basically means is that the fundamental unit of your brain is the neuron. It's a bit more complex than that, we don't really know too much, to be honest, but in a certain model, you could say the neuron is the fundamental unit, right? Because it's the interaction of many things. It's the neuron with also these accessory cells that creates the magnificence of the brain. But let's just simplify it and say it's the neuron or networks of neurons. That's the fundamental unit of the brain, right? So it's neuron A, linking up with B in certain ways, sending signals in certain patterns, and it's the emergent property of all that electrical activity that creates this consciousness and awareness and whatnot. So MSG, it gets into your system, right? So it gets into circulation, it goes all around your body. It causes these neurons to be abnormally excited. So it's an excitotoxin. It's toxic because of the abnormal levels of excitation it creates in neurons. And it can excite a neuron to the point of death. So MSG can kill some neurons in your brain over time. It's not a one-day thing. But this abnormal stimulation and whatnot, and it might manifest as a headache. It's also called like Chinese food syndrome, right? Because you go to the random Chinese restaurant, and they use all this kind of low quality material, so they make it taste good with epic amounts of MSG. So you eat all that stuff, you might get headaches, heart palpitations, sweaty feelings. That's the excitation of MSG coursing through your system. Eating far too much MSG. Paul, are you still going to eat this thing?
Yes.
Brother. So finally, very interesting is how MSG can make you very fat very quickly. And it's because of how this excitotoxicity destroys a critical region of the brain. So this is a head, this is the brain. In the brain, there's a region referred to as the hypothalamus. And the hypothalamus is a very interesting area because it's the integrator of the nervous system and the hormone system. So it brings two worlds together. It brings consciousness with emotions, with hormones, and integrates all that stuff. So it's a very interesting area. And it's also what regulates appetite and regulates energy metabolism. So there's a hormone that's produced by fat. So let's just say this is fat somewhere randomly in someone's body. Fat produces a hormone called leptin that communicates to your brain how much energy is available and whatnot. So MSG damages the neurons that constitute the hypothalamus. So the hypothalamus is no longer able to receive that signal. So you also lose all sorts of information, but part of what you lose is information about energy, appetite, and whatnot. And that makes you lose, it makes you leptin resistant. You lose the ability to control your appetite, and also makes your metabolism very sluggish because your body now thinks it's starving when in fact you're just gaining weight in a runaway fashion. So MSG can lead to obesity, and it's a very important aspect of this obesity epidemic, which is obviously multifactorial, driven by many things, that are in processed foods, but MSG is just one current in that vast stream that is driving us in that direction. So, I hope you found this talk useful. Paul, we think I just dey talk this whole time, say this thing no dey good for body.
Good.
Paul, man. So, the Biafran Medical Association has spoken, and Creative Juices as well has spoken. So, the choice is now yours. Believe who you want, Paul, or myself. Thank you so much for your time.